Alright, so now in this example, we're going to see how we're going to start forming the equation y equals mx plus c in general from a given diagram like this and information given. So basically, actually x and y are not directly linear related, so to speak. Actually, this is a graph of actually y against 1 over x. So you can think of this as the big Y and this to be the x. So naturally, if I were to write it as an equation like this, I would need two more things, right? The gradient and the y-intercept. So let's take a look. First thing we're going to find is, yes, the gradient. So we can actually freely use the points here. So in terms of a gradient, m, our international recognized symbol for gradient, I'll just apply my gradient formula. 4 minus 2 over 1 minus 3. Okay, and that gives us a value of 2 over negative 2, negative 1. Alright, so with this, I can now start to form my y equals to mx plus c expression already. Okay, so in this case, like we said, y is small y. M has found to be negative 1 multiplied by x. Now be careful, the horizontal axis is actually 1 over x plus c, which we have yet to find out. Okay, so if you simplify this a bit more, it looks just like this. Okay, so now, similar to coordinate geometry, we are going to find our y-intercept value. So to do that, we're going to substitute these values into the equation. Okay, the only thing you're going to be really careful of is this refers to the value of the horizontal axis, which is actually 1 over x. The whole 1 over x will be represented by 1. The vertical axis is represented by y. So be very careful when we do this substitution inside. So now we will let 1 over x be 1 and y be 4. So we're going to get 4 equals to negative 1 plus c. So look very carefully as how we do the substitution. Alright, so we simplify this a bit and we're going to get a value of positive 5. So now, to fully express y in terms of x, I'll go back to this, now that we know our value of the y-intercept. So we have y equals to negative 1 over x plus 5, and that's it.